So I thought it might be of use to some of you who are progressing well in this chapter on transformations of y equals x squared to see a word problem and possibly attempt to stretch yourselves a little bit and learn how to work through some of these word problems. So I'm going to model one of them for you, and that will put you in a good position to start off. So I'm going to read through the question first, and then we'll talk about some strategies that you may find useful in working through these word problems. So it says, at a fireworks display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. It's a lot of stuff there. It says, determine an equation to model the flight path of the firework. So for any of you that are taking physics, you will see similar questions in physics. You'll typically get a formula, but in this case, we're not given a formula. We need to derive one, or we need to arrive at some sort of formula. But I always find in these word problems that creating some sort of a visual, creating a diagram, is a great strategy to help you visualize what is going on. So that is exactly what I'm going to do. So I'm going to envision that we have, okay, so here we have some sort of distance that is 2 meters above the ground. All right, so this distance here, from here to here, is 2 meters. And we're going to take some sort of a firework, and we're going to launch it. I'm going to make that, I'm going to just remove all of this down a little bit, just so that I have a little bit more room. All right, so there we go. So my firework is going to be here if I'm launching it 2 meters off the ground. And so what I'm going to see is it's going to travel in a parabolic path, as I would expect, right? So and I don't know how far it's going to go right now, but we'll sort of leave it at that. And so it's telling me a few other things. It's saying that it's 2 meters above the ground, reaches a maximum height of 40 at a distance of 10 meters. So if I find what I would consider the top point in that parabola, I'm going to kind of locate that. So this is just my diagram, so the accuracy doesn't matter so much. I know that that at that point, that's a point where the distance from the ground is going to be 40 meters, and the horizontal distance is 10 meters. So now I can think of this as a bit of a coordinate system of sorts. So, I'm going to draw in, I'm going to overlay a graph on top of this. So I can think of this as being an x and a y and an x axis. And that will help me to lay out some coordinates for myself. So right here, if I'm considering this point right here to be my origin, that allows me to set out some other coordinates on this graph. So for example, I can suggest to you that the starting position of the firework is at 0 and 2 meters. So I'm going to create a coordinate 0 and 2. And by the same token, I'm going to consider, remember that this coordinate right here, the maximum, is really just the vertex of the parabola. And it is at a horizontal distance of 10 and a vertical distance of 40. So there I've set out another coordinate for myself. So I'm going to write that out. So 10 and 40. And so you'll recall that in yesterday's lesson that we learned how to take two coordinates and create an equation for a parabola given that. And so I have all the information really that I need to do that. And so I'm going to start to undertake that. I'm going to need a little bit more room, I fear, so I'm going to just squish this down just a wee little bit. All right, so I know that the sort of standard equation is going to be y is equal to a times x minus h all squared plus k. And since I have my vertex, I also have h and k. And so I can go about inserting those into the equation that I have so far. So y is equal to a times x minus 10 all squared plus 40. And there's nothing for me to clean up there. But I also know that I have, in order to figure out what the value of A is, in other words, whether this has been stretched at all, I can plug in my other coordinate in order to do that. And so I'm just for X and for Y in this function, I'm going to sub in the starting position of that firework. Now there's a couple things I should already anticipate, and I find that it's useful for me to look at, what I have in front of me and to anticipate what I should see. So there's a couple of things I want to point out to you. First of all, this parabola is opening downward. So that should give me an indication about what I should expect from A. I should expect that A value should be negative because my parabola is opening downward. So if for whatever reason I end up with a value of A that is not negative, that should be suspect to me, and I should go ahead and review my answer. All right, so now I'm going to go ahead and plug in that value that I have for Y and for X. So the value of X at that starting position, or Y, was 2. And I'm going to keep going from there. I don't know what A is yet. I'm going to go ahead and substitute in 0 for X as I had before. And now I'm in a position where the only unknown is A. And so I just have to simply solve for A, and I'll have had the value, substitute that back in, and that will give me an equation for the parabola that's described in this problem. So let me go ahead and do that. So I have 2 is equal to A times, it looks like I have negative 10 all squared plus 40. I'm going to apply my BEDMAS rules here, and I've done what was in the brackets. Now I'm going to look at my exponent here and deal with that. So negative 10 squared is 100. So that, cleaning this next step up, I'm going to have 2 is equal to 100A plus 40. Right, I'm going to now take my 40 and move it over to the other side of this situation. So I will have 2 minus 40 equals 100A. And again, feel free to skip the steps. I'm just showing them for clarity's sake. So negative 38 is equal to 100A. Now, at this point, I'm going to isolate my A by dividing out 100 on each side, and I can see that the value for A that will result will be negative. So I have negative 38 over 100. In this case, it's a word problem, and so keeping that value as a fraction may not matter. I would say that if my denominator here was, a third or a sixth, then I would consider leaving it as a fraction. But I know that when I divide negative 38 by 100, I can end up with a nice decimal that is non-repeating. So I'm going to go ahead and do that. So A is equal to negative 0.38. So finishing this off, I'm going to create a nice box for myself for my response, just to clarify it in here. The equation of my parabola is going to be y equals negative 0.38 x minus 10 all squared plus 40. And so there I've tackled that. There are 2 other parts to this question that now we're going to take a look at. So let's examine part B of this question. It says, the firework continues to travel an additional 1 meter horizontally after it reaches its maximum height and before it explodes. What is the height when it explodes? So I didn't keep my picture here, so I'm going to just quickly create another diagram of that situation so that I can record it. So, we'll remember that I started off here, I had a maximum value, and that value was at 10 and 40, so 0 to 10 and 40. But it's going to keep going another meter, right? And so I have a coordinate for that. So it's going another meter, which means that it's going to have an x value that is 11. Now, how do I know that? Well, if it was at 10, and it's going an extra meter in the horizontal direction, then its position at this point is 11 meters away from its starting point. Remembering that I'm considering this to be sort of like an XY coordinate system. And so, but what I don't know right now is I don't know y, and that's what the question is. The question is asking me, well, what is the height when it explodes? And so in order to discern that, I need to solve for y for that particular horizontal position. And so I have our equation up here that we solved in part A of this question. And so I'm going to utilize that by substituting in our known value for x into the equation. I can then solve for y, which will give me the vertical position when x is equal to 11. So I'm going to go ahead and do that. So I have y is equal to negative 0.38 times x minus 10 all squared plus 40. Now substituting in my known value for x, I want to know when x is 11, what is my value for y? All right. I'm not making really great use of my space here. So let's work through that, and if you want to pause the video, try it, and then go ahead and resume when you're ready. 10 minus 11 is going to give me 1 squared plus 40. Y is equal to negative 0.38 plus 40. And now I just have to simply do the subtraction, and I should be good to go. Okay, so that gives me 39.62. And so I need to remember that that is actually a value that has meaning. The question doesn't really tell me how to round, and so I'm not going to. And so feel free to, when it doesn't describe how it should be rounded in math, then you just can leave it in whichever form that makes the most sense. So this is a value that represents a height, so I'm going to include meters in this case. And so there it is. So therefore, the firework explodes at a height of 39.62 meters. Okay, and so in part C of this question, it's asking us about at what other horizontal distance is the firework at the same height as part B. So I'm just going to quickly sketch out what we have so far. We have our firework. It's going to land probably not that far. There it is. Here's our max. And so if it's exploding right here at a x value of 11, and now we know what the y value is there, we need to remember that this parabola is symmetrical about that vertex, about that axis of symmetry. So if there was a horizontal distance of 1 meter to the point where it explodes on one side, then all I need to do to answer this question is to recognize that to find a similar point on the parabola on the other side of that axis of symmetry, and now I haven't drawn this particularly well, but I know that due to the symmetrical nature of the parabola that I'm going to find what the coordinate is that has the same height by looking at 1 meter in the opposite direction. And so 1 meter in the opposite direction, if my vertex is at 10, a horizontal distance of 10 and 40, then I know that my parabola is going to give me a value of 10 minus 1 on the other side, or an x-coordinate of 9 and some other value of y. So that's basically it. We're going to use those symmetry properties to allow us to answer that question. So again, we have our, I'm just going to remind you, the parabola, this firework's going to go up, 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 and then it's going to go down, 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 and so I can use that mirroring property of my axis of symmetry to locate the other position where I'm going to have a height of 39.62 meters. And so that is it. So I'm going to assign you some word problems for you to attempt if you're game for it, just to stretch your understanding a little bit. And if you struggle with it and you want some assistance, as always, feel free to reach out.